Solve problem on balancing of several masses rotating in different planes by using graphical method. Given question: a shaft carries four masses A, B, C and D of magnitude 200 kg, 300 kg, 400 kg and 200 kg respectively, and revolving at radii 80 mm, 70 mm, 60 mm and 80 mm in planes measured from A at 300 mm, 400 mm and 700 mm. The angles between the cranks measured anticlockwise are A to B 45, B to C 70 degree and C to D 120 degree. The balancing masses are to be in planes X and Y. Distance between planes A and X is 100 mm, between X and Y is 400 mm and between Y and D is 200 mm. If balancing masses revolve at radius of 100 mm, find their magnitude and angular positions.
In this question, four masses are rotating in planes A, B, C and D about the shaft. Two balancing masses are provided which are rotating in planes X and Y. We will first construct the diagram for the arrangement of masses in different planes as per the given data. Now we will first decide the distance. If we observe the distance in between planes, that is length A to B, that is in between A and B distance is 300 mm, in between A and C distance is 400 mm and A and D distance is 700 mm. So we will first plot this. So we will take here LAB. So first we will plot the A. So what is the radius of rotation for this A? So radius of rotation is given 80 mm. So we will take the approximate distance, that is equal to 8 cm, and we will mark here this mass MA. So this mass MA is 200 kg. So we will mention here 200 kg, and this is the plane A. Now B is at 300 mm. So again we will take here approximate distance. So for 300 millimeter we will take 3 multiplied by 3, that is approximate 9 cm distance. We will mark here one point and we will again draw here one vertical line. So this will be the plane B. So we will mention here B. Now what is the radius of rotation for the B? So RB is 70 mm. So we have to take approximate 7 cm distance and we will mark here. And this mass MB is 300 kg. Now again we will move to the next, that is LAC, that is 400 mm. So again 4 multiplied by 3, that is we will take 12 cm distance from this A and we will mark here C. So again what is the radius of rotation for C? That is 60 mm. So approximate take 6 cm distance and we will mark here. So this will be the plane C, and what is the mass? Its mass is 400 kg. Then we will move next, that is LAD. So it is 700 mm. So again from this A we will take approximate distance, that is 7 multiplied by 3, that is 21 cm, and we will mark here one point. Now what is the radius of rotation for this D? That is 80 mm. So again we have to take 8 cm distance and we will draw here. So we have to take this equal distance as A, and here this will be the plane D. So its mass is 200 kg and we have to mention this. So these planes that we have plotted as per the given data. So we have to take particular scale as per the given data. Now we will move next. Now two balancing masses are provided at planes X and Y. So here this information also mentioned, that is LAX from A the distance of plane X is mentioned, that is 100 millimeters. So take approximately 3 centimeter distance and we will mark here one point, and here will be the plane X. So this is unknown mass because mass is not provided. Radius of rotation for X is provided, and that is equal to 100 millimeter. So for 100 millimeter we have to take 10 centimeter distance, and here we have to show the mass. Now this is the balancing mass, so it is at plane X, so we will say that m to the base x. Now this is unknown and we have to find out. Then in the same way, Lxy is also given. Now from x, this distance to y is given, that is xy. In between x and y, distance is 400 millimeters. So according to scale, we can take here the distance, that is 12 centimeter, and we will mark here one point. And again, radius of rotation is also equal to 100 millimeter. So we will take here 10 centimeter vertical line, and we will show here one circle, that is the mass, and this mass is at plane y, that is my. So this is also unknown, and that we have to find out. Now we will move next diagram. So this is the arrangement of masses in different planes. So on this horizontal line we can here mention the distance. So I will just draw here the horizontal line, but we will mention the distance. So we have to make here the partition. So this partition is important. So the standard unit is in meter. So remember, we have to mention this distance in meter only. So in between A and X, it is 100 millimeter, that is 0.1 meter. Then in between A and B, it is 300 millimeter. So in between X and B, it is 300 minus 100, that is 200 millimeter. So here is 0.2. Then in between B and C, so here in between A and C it is 400, and 400 minus 300, that is here is 100 millimeter. So I will write here 0.1. Then in between A and D it is 700, and in between X and Y it is 400, that is 0.4. So 0.4 minus 0.3, then it is 0.1, and here remaining is 700, that is 0.7, because A and D distance is given. So 0.7 minus 2 plus 3 plus 4 plus 5, that is 0.2, remaining is 0.2. So in this way we have to mention the distance. Now this diagram is getting completed. Now we will move to the next, angular position of masses. Now here, if we observe the question, the angles for the masses B, C and D is given. Now the angle for mass B is given with respect to A, and with respect to A it is 45 degree. Now angle for mass C is given with respect to B, and it is with respect to B 70 degree, and for D it is mentioned with respect to C, and it is 120 degree. So if we assume theta A is equal to 0, then how to show here? We will consider one center point O, and we will draw one line at an angle of 0 degree. So here is O. So we know that we have to measure angle in this anti-clockwise direction. So this line is at 0 degree. Now how to draw this theta A? So for that we have to refer this RA, which is equal to 8 millimeter. So we will take here distance of 8 millimeter, and we will draw here one line, and this is for MA. Now B is given 45 degree. So with the help of protractor, keep the protractor here and mark one point at 45 degree angle. So this 45 degree angle B is there, which is equal to 45 degree, and RB is 70 millimeter, that is 7 centimeter we have to consider, and we will draw here one line. So this will be MB. and which is at 45 degree. So we will mention here 45 degree. Now next is C. Now in between B and C angle is given. So from A, what is the total angle? 45 plus 70, that is 115. So this is the line at 115. So RC is 60 millimeter. So we have to take a distance of 6 centimeter and we will join here. So here is MC. Now we will move next theta D. So it is with respect to C is given. So after C the angle is at 120. But before, theta C is equal to 115 from this A. So 115 plus 120, that is 235. So what is theta D? That is RD is 80 millimeter. So we will take 8 centimeter distance and we will mark here, that is MD. And now we will mention this total angle, and this angle is 235 degree. So this is the second diagram for the angular position of masses is getting completed. To solve the question by using graphical method, we have to first calculate the centrifugal force as well as couple. To draw the force polygon as well as couple polygon. Now we will prepare one table. Now in the first column we have to mention planes. So with reference to this diagram, in the sequence from the left hand side towards the right hand side, we have to mention the different planes. So first plane is plane A, then next one is X, then B, C, Y and D. So we will mention, because this mass is unknown, so I will mention here with red marker. Then after BC it's a Y, and then last one is D. Now we will mention the mass. So mass M in kilogram. So for A it is 200 kilogram. Then for X plane the mass is unknown, so I will write here mx, then it is 300, 400, then my and then 300. Here is 200 kilogram. So for at D it is 200 kilogram. Then next radius R. So here is the radius of rotation. So if we observe the question, then the radius of rotation for all masses is mentioned in the question. For A it is 0.08 meter. So this radius we have to mention in meter. Then for this X it is 0.1, then 0.07, then 0.06, 0.01 and 0.1 and 0.08. So this as per the question we have to mention. Then we will calculate the centrifugal force. So what is the formula for centrifugal force? That is mr omega square. And all these masses are rotating about this shaft with an angular velocity omega. So this angular velocity is same for all these masses. So we will consider centrifugal force is equal to m into r, and its a unit is kilogram meter. So we have to just multiply this mass and this r, that is the radius of rotation, that is 200 into 0.08, that is equal to 16. Then here 0.1 into mx, that is 0.1 mx. Then next is 300 into 0.07, that is 21. 400 into 0.06, 24. Then here my into 0.1, that is 0.1 my. And here 200 into 0.08, that is 16. Now next is L. So L is nothing but the distance of all planes from the reference plane. Now if we observe these planes, then at the plane X and at the plane Y there are unknown terms, that is mx as well as my. So we have two options to choose the reference plane. We can either choose the plane X or we can choose the plane Y. So I will select the plane X as a reference plane. So I will mention here this is reference plane, that is plane X. Now how to mention this L, that is the distance of the different planes from the reference plane. So if we observe for this plane A, so what is the distance from the reference plane? That is 0.1. But also we have to refer the direction. So while showing this value L, the planes on the left hand side, for the reference plane we have to show with negative number, and planes which are on the right hand side we have to show with positive number. So here 0.1 we have to show with negative, that is minus 0.1, because it is at the left hand side, so minus 0.1. Next one, x. So reference plane is on this plane x, so we will take here as a 0. Then next b. So b is at a distance of 0.2 and on the right hand side, so plus 0.2. Then next is c. So c is 0.2 plus 0.1, that is 0.3. Then y. So y is at 0.2 plus 0.1 plus 0.1, that is 0.4. And d. So d is at 2 plus 2, 4, 0.6. So these are the values of L. Now we will move to calculate couple. So what is the formula for couple? That is this force multiplied by this axial distance in between plane, that is L. So MRL, and its a unit is kilogram meter square. So we have to just multiply these two columns, that is 16 into minus 0.1, that is minus 1.6. Then here the second term is 0.1 mx into 0, that is 0. Then 21 into 0.2, 4.2, 24 into 0.3, 7.2, and here 0.1 my into 0.4, that is 0.04 my. And last one 16 into 0.6, that is 9.6. Now we will move next, that is the theta, angle in degree. So we will refer this diagram. So what is the angle for A? So A plane is having angle 0 degree. Then X. So this angle X for X plane is not known. So we will say here as a theta X. Then for B, so B is at 45 degree. Then C is at 115 degree. Then Y. So this angle is also unknown, so we will write here theta y, and for D it is 235 degree. If we compare the values for force as well as couple, then for force there are two unknown terms, but for couple there is only one unknown term. So we will first draw the couple polygon. So scale we will take 1 centimeter is equal to 0.4 kilogram meter square. So first plane is plane A, and its value is minus 1.6, and plane A is at an angle 0 degree. So we have to reference this diagram also. So this plane A is at an angle 0 degree. Now due to negative sign we have to show the line towards the left hand side. So first we will consider one reference point, that is point O, and as per this scale 1.6 divided by 0.4, that is 4 centimeter line we will draw, and the direction is towards the left hand side. So we have to show direction also. So this is the reference point O, and this is the point small a for this plane A. Now because direction is because of negative sign. Now next we will consider for this plane B, because for plane X it is 0. So next is plane B. Now this plane B is having value 4.2. So as per this scale 4.2 divided by 0.4 is equal to 10.5 centimeter. Now if we observe angle for this plane B is at 45 degree. So we have to draw here one line of 10.5. So initial point will be point A and final point will be point B for the plane B. So with reference to this angular position diagram, we will transfer this line at a 45 degree. So we will take here 10.5, and now this angle is 45 degrees, so this point is point B, and now we will show arrow also. Now next is plane C, which is having couple value 7.2. So as per this scale it is 18 centimeters. So what is the angle? So angle for this plane C is 115. Now we will transfer the same line. So we have to draw here 18 centimeter line with the same angle. So here we will draw 18 centimeters. Now next point will be point C. We will show arrow also. Now we will move next. So this y is unknown term. So for D it is 9.6. So 9.6 divided by 0.4, that is 24. So D is at an angle of 235 degrees. So again we will transfer this line and we have to draw here 24 centimeter line. And here last point will be point D. So we will show arrow also. Now we have to close these lines. So because this couple polygon should be closed, so I will close this line. So here is the last point, that is we will say, because remaining only y, so I will consider this point as a point y also. Now we will plot the value. So here this is the couple polygon. So what is the value from O to A? That is minus 1.6. So because we have shown here direction towards the left hand side, so I will mention only 1.6. Then next is for B, it is 4.2. So I will mention here. Then next is 7.2. And next is 9.6. And here what is the value? So value for this is 0.04 my. So I will mention here 0.04 my. Now we have to measure this scale and we will find out what is the value of this my. If we measure this distance D to y, then it is 18.5 centimeter. So we will multiply with scale 0.4 and then it is equal to 7.4. So this length, that is equal to 0.04 my. So we will calculate the unknown term my, and that is equal to 185 kilogram. Now we will measure the angle theta y. So if we measure this angle, so at this point D, if I draw here one horizontal line and then we will measure this angle. So this angle, that is equal to 347 degree. So we will transfer this line in this angular position diagram. So in the same way, I will, with the help of this roller, transfer this line parallel to here. So we will draw this line and we will, this is y, that is we will say that my is there. So here we will show my, and this my we have found, that is 185 kilogram. And this angle we have to show. So from this total angle is 347 degree. Now we will move to the fourth polygon. So for the fourth polygon, we will consider scale 1 centimeter is equal to 2 kilogram meter. So as per this scale, we will move for the first plane A. Now for the first plane A, if we observe, it is 16 kilogram meter. So as per this scale, we have to take 8 centimeter line. Now if we observe the angle for A, then it is at 0 degree and it is having plus sign, that is positive sign. So for positive sign, we have to draw the line towards the right hand side direction. So I will draw here one line, and which is having length 8 centimeter. Here. Now we will show arrow also. First point is O and last point is A. Now we will move next. So for the next X, that is unknown term, so we will move next, that is for B. So B, it is 21 kilogram meter. So as per this scale, 21 divided by 2, that is 10.5. So for B, angle is 45 degrees. So we will transfer the angle from this angular position and we will draw here one line, and length, that is equal to 10.5. So at 45 degree, 10.5. So here last point is B and we will show arrow also. Now next is C, and which is equal to 24 kilogram meter. So as per this scale, 12 centimeter we have to take. Now for C, angle is 115. So again I will transfer this and we will consider here 12 centimeter, and last point will be point C. Now next one, Y. So now my is known, 18.5 into 0.1. So 18.5 into 0.1, that is 18.5. So as per this scale, 18.5 divided by 2, that is approximately 9.2 we will consider. So for Y, angle is also known. So if we observe this angle, we have to transfer this and from C we add this angle only, we have to draw the line. So its length will be 9.2. So here, and last point will be point Y. We will show arrow also. Now for the D it is 16. So as per scale we have to take 8 centimeter, and for D this is the angle, that is 235. So we will transfer the same angle, and now we have to take 8 centimeter. So this is the point. So after Y this point will be D. So we will show arrow also. Now we have to join this. So how to join? So because this first polygon should be closed, so we will join this point D and O. Now for the first polygon we will mention the value. So first plane is plane A. So this is the line representing O to A, and its value is 16. So I will mention here. Then next is B. So A to B is 21. Then next is C. So in between B to C it is 24. Then C to Y. So 0.1 into my, that is 18.5. And then Y to D it is 16. So we have to mention here. So now if we close this D to next unknown point X, so here we have to mention this point X also. So D to X is value is 0.1 mx. 0.1 mx. So if we measure this distance D to X, then it is 17.5 into 2, and that is equal to 35. So its value is 0.1 mx. So mx is equal to 350 kilogram. Now if we measure the angle, so at point D we have to draw this horizontal line and we have to measure this angle, and this is 212 degree. Now we will transfer the angle in this angular position diagram. So we will take the line parallel to this and we will mention here, and this is mx. So what is the value of mx? That is equal to 350 kilogram. And angle it is 212. So we have to mention here this angle 212 degree.